Assalamu alaikum, respected audience. My name is Qulzam Zahid, and today the topic we are going to present for our research paper is trajectory pattern mining for urban computing in the cloud. Our team members include, first of all, me as well, Qulzam Zahid, Sheharyar Kamran, Afaq Tahir, and Hamza Ashfaq. So the contents that we will be covering in our presentation is, first of all, like problem that describes the problem discussed in the paper. Second, prior work. We will be mentioning some prior work in this area. Third, solution, that how the problem is solved. Fourth, methodology, which methodology is used in this method. And fifth one is dataset that tells any dataset used for simulation and analysis. And at the last, results and discussion. So first of all, problem. In this, I'm going to describe the problem discussed in this paper. Basically, this paper describes a system parallel method for identifying regularities from trajectory data, which is implemented on such a cloud-based urban computing platform. The second thing that the scenario discussed in this search paper relies on the evolution smartphone trajectories with the goal of discovering information. It's indeed that it's a difficult challenge to deduce periodic trends from past object movements. And among the most difficult problem in urban computing is that how to figure out the mobility models, how to find out mobility models. So furthermore, I would like to include the widespread usage of mobile devices along with technologies such as Wi-Fi networks, GPS, and sensors enables for the processing of vast volumes of movement data. And this volume of data could be processed to provide predictive and descriptive frameworks which can be used to transform urban life by the method of acquiring, integrating, and analyzing large and diverse urban data to address major problems that cities face. This includes such as air quality, energy use, traffic patterns, human mobility, environmental protection, some economic operations, and cost cutting in government expenditures. These are some major problems that cities face. So how can we abstract our approach to real world data sets? By implementing the trajectory pattern abstracting approach to real world data sets involving resident mobility in a city. Because the trajectory pattern mining method is capable of flexible delivery infrastructure provided by the cloud, given the difficulty and significant data included throughout the proposed methodology, according to the experiment conducted on a public cloud platform. Because the trajectory pattern mining method is capable of flexible delivery infrastructure provided by the cloud, given the difficulty and significant data included throughout. Because the trajectory pattern mining method is capable of flexible delivery infrastructure provided by the cloud, given the difficulty and significant data included throughout the proposed methodology, according to experiments conducted on a public cloud platform.
Prior work. Some of the prior work are mentioned in this area. Prior work. For local populations, for keen local populations, some special plans and board application assist cloud have recently been proposed. The cloud uses EVOP to achieve similar goals in the area of land and sea. Basically, EVOP is a if we look into the EVOP is an environmental visual observatory pilot. Environmental managers and policymakers face challenging futures, trying to accommodate growing expectations for environment well-being while subject maturing regulations, constrained budgets, and even a public even a public scrutiny that accept easier and more meaningful access to the data of the decision of the logic. To support such a challenges to support such a challenging such challenges, new tools have been developed, or we can say that that new tools have been approached in the market, have been introduced. Basically, the EVOP or the Environmental Virtual Observatory Pilot is an initiative from UK National United Kingdom Natural Environmental Research Council designed to deliver proof of concept for the new tools a series of big catchment science questions are posed, and new prospects have been and new prospects for their solutions are being assessed. So, on the other hand, even the European Platform for Intelligent Societies distributed computing engineering with the knowledge and skills. Furthermore, if we look into the smart city solution of the IBM Shared Cloud Enterprise, a public cloud stage uh, includes equipment organization and capacity. Uh, Basically, the smart city solutions and the IBM Shred Cloud Enterprises includes equipment, organizations, and capacity. On the other hand, uh, the most complex problem in cloud computing is the recognition of adaptability models, which is according to the research paper, uh, is also one of the is the prior work that has to be that has to be focused, or that has to that has to be looked into it, that the researchers have looked into it. Uh, mobile phone data, for example, can be used in used to build the construction models that can later on help the city planners with transportation planning, traffic, and path recommendations. Uh, there are two task destinations as mentioned below. Creation of the cloud-based processing climate for productivity, and for building the procedure for examining cell phone gadgets for separation of social and natural information, which is also one of the prior work that the researchers are trying to do in this research paper. Uh, as the large the structure has been designed, the set of distinct segments that allows easy extensibility and coordination of disparate cluster segments.
So now I'm going to tell the solution, that how the problem is solved. So basically, in such a cloud-based application for urban computing, trajectory pattern mining is used. Because they presented this problem-solving concept of the application framework they created for the delivery of programs aimed at optimizing development. And it was for controlling and tracking operations inside an urban framework for solving problems like health, smarter transportation, smarter homes, smart tourism, and intelligent public services inside an urban world. Therefore, by enabling access to the data and storage throughout networks, lifting on-demand processing tools, and combining data analysis and data processing for technology, the cloud-based computing model allows for the deployment of all the above urban facilities as discussed earlier. And furthermore, I would like to include the methods used in this methodology is that the data acquisition layer enables connectivity to environmental data obtained from various sources for the purpose of monitoring municipal resources, just such as quality of water, electricity use, and so on. And the second layer for this method that includes service composition layer that is in charge of assisting users in the development of application workflows, identifying sources of data, and connecting the required computing components to execute the workflows. And so finally, the solution is that the smart urban software system layer provides a collection from the above solutions that I discussed earlier for the urban development.
part is methodology. I have to present which methodology is used. The trajectory pattern extraction methodology allows to predict future movements of citizens in order to support decisions in urban contexts. The set of trajectory pattern extracted represent a basic building block around which further tasks can be implemented, including the following. So, next, first one is next location prediction, second intelligent traffic management, third movement similarity analysis, fourth travel recommendations. First, I will go over the methods for extracting trajectory patterns from routes taken by consumers throughout their everyday routines. The trajectory pattern mining approach is extended to study moving objects by the authors. Any method of varying difficulty are suggested, and their advantages and shortcomings have been empirically tested using actual evidence and computational benchmarks. There are three key phases in the method used to find trajectory pattern. Figure depicts how trajectory variations are found graphically to help explain the entire process. The research input data is a collection of actual trajectories derived from a sample of actual trajectories followed by users throughout their everyday routines. There are three steps. First one is frequent regions detection. The algorithm's first objective is to establish recurrent areas in the pure trajectory datasets. The aim of this phase is to identify densely parsed over spatial areas so that more research can be done as movement through areas instead of single points. The second step is trajectory data synthesization. The trajectories are then synthesized by adjusting their interpretations from movement between points to movement among frequent locations in the second process. Each point inside the original dataset is replaced by the area to which it corresponds. The third step is trajectory pattern extraction. The, the third stage involves studying the trajectories of regular regions acquired in the previous step and obtaining trajectory patterns throughout the context of associative laws.
Okay, so moving on, talking about the dataset that is used in this project. Before going on the actual dataset, there are two couple of things that need to understand about the dataset. The dataset used for this project purpose is consist on the daily usage of the mobile and the other electronic devices which share their data through the GPS, Wi-Fi networks, and the other sensors. And the other point is that it is an urban data using for the computation and analyzing pattern to identify the usage of the devices in urban cities, hence providing the computation system solutions for the heterogeneous urban cities. And it is the example given that data generated by the using mobile devices produce movement patterns that can be used to support the decisions of the city managers in transport planning, intelligent traffic management, route recommendations, etc. There are two type of datasets. The first one is the real world dataset. It is concerning the mobility of the citizens within an urban area, and the other one is a synthetic dataset. It is built by a trajectory data generator, which is 80,000 input data to 1 million data. And how the dataset is collected? Dataset that have been used for this project is built by an ad hoc trajectory data generator that we designed and implemented. So some other key points of the dataset is the count of vehicles tracked is 10,357. 15 million of the locations, that means the geographical points. And the total area covered by the tragedies reaches almost 9 million kilometers. Hence, the data was the total of around 80,000 trajectories, and then they divide them into the four subsets. That reference to the timestamps as T16, T32, T64, and T28. These four datasets are used in the experimental evaluation, and before testing out the trajectories, pre-processing tasks has been performed to clean, select, and transform data to make it suitable for the analysis. There were there were two-step dataset cleaning. The first one was removing all the points in with the unreliable positions. And the other ones to make the data geolocalized errors free, we only select the data points falling in the limited boundary area. And in the end, we transform data by partitioning each trajectory in a daily route. Hence, the final dataset after cleaning contains about the 61,500 daily trajectories, and the total size of the dataset is 882 MBs.
So now at the last towards the conclusion, I will be showing you results and having some discussion. So basically the thing that was discussed in this research paper or the method that was implemented is that a cloud-based virtual world was personalized uniquely for urban computing that supports smart city implementations. So in this methodology, they developed and introduced a parallel technique for pattern recognition throughout trajectory data in such a framework, which was basically inspired by workflow architecture. And so basically the methodology's key concept is just to identify the most highly spread over areas inside a specific geographical location, and afterwards drive trajectory characteristics in the context of association laws from such locations. And yes, it's true that trajectory pattern mining method in particular benefits from cloud technologies in aspects of execution time, speed, and size. And now I would like to give some opinion on this research paper, on this methodology that is described in this research paper, is that basically they must, in my view, intend to expand some more of the system feature and functionality in the future to introduce modern urban computing technologies, such as the following, like choosing the trajectory sequence models right from the study forecast the potential position of a moving automobile. That's a good point. And the second thing, that the travel guidelines that use mobility models to identify the most appropriate pathways for automobiles to take to get to a certain location. That is also a good point that should be implemented. And yes, the smart traffic control anticipates mass transit dynamics and cut down on time lost due to vehicle movement. Okay, thank you everyone. I hope that you all understood that what we described in our this presentation. Thank you. Allah Hafiz.